Hello and welcome everyone to this sixth part in this video tutorial series about OpenTK. So in the previous part we worked with the matrix transformations and we had this output. So in this video tutorial we will learn about lighting. So before you begin to add lights into your program, you need to know about normal vectors. So I'll just give you a brief description of them too. So let's get started. So we currently have two rectangles drawn in our application, but I'll remove the code for one of them. So we'll only have one cube drawn now. I'll just draw it at the center and increase its size a bit so it is clearly visible. Let's build and run and check this. Here we go, we have one cube. And so now we were using different colors to so that the faces of the cube appear distinct, but now I'll set the color of all the faces to the same color. So all the faces of the cube will now have the same color, which I'll set to white. So I'll just remove the color commands from here. Okay, so we are only setting the color at the beginning of this function, which is we are setting it to white. So our cube will be drawn in the white color. So now if you see this, you can see that you cannot differentiate between the different faces of the cube. This is because all the faces are of the same color, and now you cannot differentiate among them. So this is where you'll need lighting. So when you introduce lighting into your application, the different faces of the cube will reflect the light into different directions, and you'll be able to differentiate among the different faces. So it'll appear something like this. So one face is more bright while the other is not. So this is one of the many reasons why you'll need lighting in your applications. So for example, you draw a sphere in your program, and if you do not have lighting, it'll just appear as a circle, a 2D circle. But when you introduce lighting, because of the shades of the light, it'll appear 3D. And you can also add lighting to make the objects look more lifelike or more real in your applications. So we'll just get started with lighting now. So before introduce you to lighting, we need to know about normal vectors. So now OpenGL we need to specify, like OpenGL cannot determine that which side is perpendicular to the face. So it does not already know that in which direction to reflect the light. So like we can take the example of one square here. So now to reflect light, you know that light is reflected like this is the normal, and the angle of incidence is equal to the angle of reflection. So if the light falls this way, it will be reflected with the same angle. So angle of incidence is equal to angle of reflection. So the problem is that OpenGL, we need to specify the normal vector to the OpenGL. It does not know that by default that which side is perpendicular to the surface. So every time we draw a primitive, we need to specify a normal vector for it. But actually the normal vector is not specified for primitive. It is specified for each vertex. So it has 4 vertices, and now we'll need to specify a normal vector to all 4 of them. So now OpenGL can determine that in which direction to reflect the light. So if it falls this way, it'll be reflected like this. And if you do not specify normal vectors, all faces might reflect the light in different in unexpected directions, non-desirable directions, and that'll give the the stuff you get on the screen might not be what you expected. So that is why we need to specify normal vectors. So now it is easy to specify the normal vectors of a cube manually, but you also have algorithms for finding out the normal vectors of the surface, the mathematical algorithms, but we'll not talk about them here because I'm trying to keep this tutorial as simple as possible. So since we have a cube, it is quite easy to specify the normal vectors because the faces, the perpendicular to the faces are lie in this, like they are just the axes. Like I have a cube here, so this is perpendicular to this surface, it is perpendicular to this surface, and this is perpendicular to this surface. Similarly for the back side of the cube, so this is just the positive x-axis, positive z-axis, positive y-axis. So this is why it is easier to specify a normal vector for a cube. So like the normal vector for the back side of this cube will be this side, so that will be the negative z. So then you once when you once set the normal vector, like the color command, like I'll set the normal vector at this point using the normal 3 command, and now it takes 3 arguments, the x, y, and z value of the vector. If you're familiar with vector, this might be easy for you. So this is the front face, so the perpendicular direction will be the positive z-axis. So this is the normal vector for it. And now all the vertices you specify after setting the normal vector, this will have normal vector with this value. So all of the vertices following this declaration will have this as a normal vector. So we need these 4 vertices to have this as a normal vector, and for the next vertices we'll specify another normal vector. So this is the back direction, so it'll have the negative z-axis as the normal vector. Similarly, this is the top, so positive y will be perpendicular to it. And similarly for the bottom, it'll have negative y. So just like that, you need to set the normal vectors for all of these. For the face facing to the right side, positive x-axis will be the normal vector, and similarly to the one facing left side, negative x-axis will be the normal vector. I'll recheck if I got all of them right. Bottom, top, and back, and that's the front. Okay, so we have normal vectors for our program now, but this will not make any difference because we still haven't introduced lighting. So now to start with lighting, you need to initialize the lights when before you begin drawing stuff. So the best way to do that will be from the loaded function. So this is the event handler which is called when the window is loaded. So this might be the right place to set the lighting. So I'll just give a comment here, lighting, that the commands following this deal with lighting. So now, like we enable the depth test, we also need to enable the lighting. So after we enable, enable cap dot lighting. So after you enable lighting, if you build and run your applications, you will see that you will either not see anything on the screen, or you'll see your object drawn with a very dark color that it is hardly visible. So this is because you have now introduced lighting, you have now enabled lighting, and there is no light in your no light inside your application. So the object is not visible because there is no light. So now to create a light source, you have various light sources here, like you can there we go. OpenGL provides 8 light sources. You can set some values to them and then enable them. So these are all disabled by default, and light 0 has some default values which you can use. So 7 lights. So you can begin. So light 0 has some default values which you can directly enable. So like I can directly enable light 0. So here we have our light 0 enabled. So now it'll be visible like that. So you can now differentiate among the faces because they are reflecting the light in the different directions, as we have set the normal vectors. So the light is being reflected according to them. You can try changing the normal vectors and see how the output changes. So the light 0 had some default values, some default attributes which are already set, but now I'll tell you how to set them. So the attributes of a light, like only the light 0 has the default attributes. Other light sources will not have anything, like the light 1, it has nothing. So you need to set all of those. Although we'll just work with light 0 and we'll set these attributes now. So what are those? So the function GL.light is used to set attributes for the light sources. So first argument will be light name. So we are dealing with the light 0 here, and then second thing is the parameter name, that what attribute of the light 0 we want to modify. So there are actually there are various attributes like light parameter dot ambient constant, all of these, the diffuse, although we'll not talk about all of them here because this tutorial is basic, and so we'll only talk about the ambient, diffuse, and the position attribute. So the light is of actually there is another type of attribute which is called specular, but we'll talk about that more when we know about the materials. When I make a video about the materials, then we'll talk about that. So first thing will be the position. So we want to modify the position of the light 0, and then there's the third argument, which is of the type float parameter. So this is the actual parameter. So according to this parameter is according to the second parameter you have passed. So we want to modify the position, and so the third argument will be the position. So you need to pass it using an array. So this will be float. Light position equal to, and now you can specify a position from where the light is coming from. So the intensity of light is not affected by the distance it is on, so light position will only take effect on the direction. So I'll set it to 20 20, and on the z-axis, positive side of z-axis 50. So it is coming from the positive side of z-axis, positive x and positive y. And now this will not run, this will give an error. First the one, there is this enable cap. Okay, I forgot to set it here. So we have set the light position, and now if you try to build and run that, it'll say that it'll give an error that system drawing.color is not referenced. So this light function uses something from the system.drawing.color assembly, so you need to add a reference to that. So that depends, so how you add a reference depends on your IDE, but we have done this earlier when we added the reference to OpenTK, so you should know that. So I'll just go to project, add reference, and then I'll find system.drawing. Here it is. So I have added a reference to system.drawing in my program, so it should compile now, and there we go. So this slide is coming from the position we set. Like now you can try setting the position to the only to the right side, that is the positive x-axis only. So this will come from that. So now you can see only the right side of the cube is bright, others are dark because the light is coming from the right side. So that's why we need to set up a good position. So like this will be straight will come from the back side, so it'll just fall on the front side of the cube. And the next parameter is the GL dot. So I'll talk about the other parameter. Light parameter dot, and now that's light. We'll first talk about diffuse. So this is the light which depends on distance, which depends on the direction and the normal vector, of course. So this is the light which falls on the object and is reflected back, and it is directional. So if the light source is placed on the right side, so the right side of the cube will appear brighter. Now by changing this value of the parameter, value of this diffuse attribute, we are changing the default value for the diffuse lighting, which is present in light 0. So we also need a variable to hold that. So it also has 3 arguments, the RGB value. So if you set all to 1.0, F, the prefix for the float, it'll have full intensity of every color, which will result in white light. So if we set it to 0, this will result in red light. So, and now we have set the diffuse lighting to this value. We have changed the default value which is present in this, and there you go, you'll see something like that. So the light affects the color of the object, so it's the red light now. And now you'll notice a thing, that the color of the object that you've set is not taking any effect. So if you want to take you'll need to enable the color material so that your so when you enable the color material, the final color of the object is calculated by both the color of the light and the color of the object that you have set using the color 3f command. So now you can see the color of this cube was white, so this is now a mixture of red and white. Although we'll not talk about it yet, we'll talk about it more when we are studying about the materials. So we'll just leave it now. So we've set the diffuse lighting, and now you might encounter a problem with the diffuse lighting, that the side of the object from where the light is not falling might appear totally dark or black. So like the light is coming from the right side, and now you'll see that the left side appears black. So for that you might want just a little bit of light at every place. So that is the ambient light. Ambient light is present at every place irrespective of the position of the light source. So light, I'll just copy them here again. Light parameter dot ambient, and so this light will be present at all places. So I'll just declare another of this, ambient equal to, now I'll set the light ambient to full intensity white color, and okay, I need the postfix for the float. There we go. Now this is not completely dark, the left side is not completely dark, but it has somewhat of white color. So I can also try changing the color of the ambient light to red, and now this will not appear completely black, it will have some red color all over. So there is a little bit of red light present everywhere, which is ambient light, it is not directional. So I'll change the position of the light back to what it was earlier because it looks good. So you need to decide the position of the light yourself. So now it is appearing too bright because I increased the value of ambient light too much. I'll just keep it 0.5. This is a quite desirable value. There we go. So we have done a lot of things in this tutorial about lighting. We first added normal vectors, then we added the ambient lighting, then we added the diffuse lighting. So now another thing I want to tell you is that you're not limited to the 3 arguments inside the inside these parameters, the light diffuse or light ambient or light position. You can use array of 4 parameters. So in the case of the color of the light, that'll be the alpha value, but we have not studied about we do not know yet about the blending or the alpha value, so we'll just ignore the 4th parameter. You can set it to 1.0, or you can set it to, you can just pass 3 arguments. This will not take any effect unless you have enabled blending in your application. So we'll talk about more about the 4 parameters when we learn about blending. So this is all for this video, and I'll see you next time.